To get going, welcome everybody. This is a CloudBank presentation or Cloud Clinic, and it has a lot to do with the strategy for stretching a cloud budget, since we know that cloud computing is regarded as a costly way of getting our computing tasks done. So I'm addressing you in sort of a dual role. I work at the University of Washington, and I do a lot of cloud advocacy there. And that's sort of across the campus for research or research-oriented uses of the cloud. And then CloudBank is sort of the same idea, but distributed nationally in the U.S. It's in a large measure to National Science Foundation funded projects, but to other projects as well. So the overall objective of our work then is to demystify and make cloud computing accessible in cases where it makes sense. It doesn't always make sense, but there are often times where it does. So we want to address that. And I'd like to encourage you to, if you have questions while I'm presenting here today, please don't hesitate to hop on the mic and let us know or put them in the chat. And somebody can get my attention and we can try and address them as we go. Let's see. So in addition to talking about the sort of stretching the budget, I will also be going over some baseline terminology. It seemed like we have a fair number of people attending, so that's great. And the first point that I'd like to make about cloud computing is that you have to be willing to invest time in understanding it. And the project that I've been working on primarily with Urjit, but also with Naomi here on the call, is to investigate using preemptible instances on cloud platforms as a way of getting a cheaper rate of computation cost. The other thing I want to mention, so I'm just going to be kind of dropping observations as from our work as we've gone, is that if you come up with a concept or a cool thing to do on the cloud, it's often a good idea to check for a service that may already exist that does what you have in mind. This is obviously to help reinventing wheels. But for example, we've discovered that the container services can be run on preemptible instances. This is a discovery that Urjit made while he was investigating this stuff. So if you're tempted to invent something new, just make sure it's not already been invented. And then I'm going to go over jargon. So just to sort of set a beginning level playing field, VMs are virtual machines. Those are computers on the cloud that we rent by the hour typically. Containerization is something I'll talk about a little bit more later, but it's basically kind of a virtualized virtual machine that runs on another virtual machine. Serverless functions are functions that are fairly lightweight and can be instantiated without, as the name implies, having an underlying server to worry about. Managing servers is a big task on the cloud, so if we can get away with not doing that, then that's a savings on our time. Spot market refers to an excess of computing capacity that clouds will tend to have, and they've come up with the idea of making those available at a drastically reduced rate, but with a catch. Checkpointing is a reference to within computing simply pausing a computation and storing the state of that computation in some kind of storage medium that's going to persist. And we'll get into that more too. And then finally, the term endpoint gets used a lot. And in my way of thinking, an endpoint is sort of a resource associated with the URL that you can point to and interact with in some way. So with that down, CloudBank has a kind of a model of a research team as having 4 different roles. So the research team has some kind of principal investigator running the show. And then the second role is an administrator. There's a subscript $sign there indicating that that person deals with getting the bills paid. And then we get to the third role, which is builders. And that's the one we're here to kind of address today, which are builders are often just simply members of a research team who are brave or foolhardy enough to take on the task of building the compute infrastructure. And if that's a simple task, then they can do that job and move on to other things. But building infrastructure can become a complicated task. And so when that happens, we at CloudBank like to try and take steps to demystify and make that easier. So we've created a fair amount of content, and we're always looking for tasks and themes and patterns that we can address that will hopefully benefit multiple research teams out there. And then finally, of course, you have the users who are supposed to be using the cyber infrastructure. So there's a great deal of overlap between these different roles and people. But the bottom line is that the builders may face a perceptual challenge, which is, I don't know how to do something. And so that's what we kind of want to address. We want to demystify that and get you on the road. So the case study that I'll tend to refer to in this brief talk today is the task of training a convolutional neural network on 10,000 small images. The data set's known as CIFAR-10. And this was selected by Urgit as a relatively easy thing to do. And that runs in a sort of cyclical or epoch-based processing run that takes maybe 5, maybe 10 minutes. Those 10 circulations of the training process are called epochs. And the idea is then to be able to pause after the end of one epoch and before beginning the next one to save the state of the computation. Let's see. The cloud value, the last bullet here is just an observation that if you have 10,000 tasks to run and it costs you $10,000, then your value is the ratio, which would be 1. And if, on the other hand, you're able to do 30,000 tasks for the same budget, then your value parameter goes up to 3. So that's our goal here, is to do that. And I'll mention that the first step that's maybe not obvious to a beginner to the cloud is to simply turn off or stop a machine, a cloud virtual machine, when it's not in use, and that can drastically cut your spend. But going a step beyond that is what we're talking about today with preemptible instances. So I'm going to refer to Urgit's repository on GitHub, with the key program being index.py. I'm going to refer to, again, as I mentioned, the CIFAR-10 image classification task. But this repository also describes the an ImageNet task that's kind of related, but maybe a factor of 100 more computation involved. And then there's also some work in there on sentiment analysis with the BERT model. The overburden problem that's referred to in the bottom of the slide, I want to take a moment to address, which is ideally, for example, if you're working with CloudBank, you would have access to multiple clouds. And the problem with that is if you are a builder and you build infrastructure that's customized to one of them, it speaks that cloud's language, then it's not translatable. However, with the people at UC Berkeley have a project called SkyPilot, which is intended to take advantage of containerization to use multiple clouds at once, and in particular to find the cheapest instance on which you could run at any given moment and deploy a workload to that location. And then if that goes away for some reason, then SkyPilot aspires to be intelligent enough to relaunch the task, perhaps on another cloud. And again, we have this idea of containerization being something that does translate from one cloud to another, and therefore addresses this overburden problem of not having to learn 3 different languages to do some kind of compute task. Again, this is the optimization of your effort as a cyber infrastructure builder. So to elaborate a little bit further on containers, the containers are hermetic hosted Linux environments. If I'm misspeaking, my colleagues can correct me. There are 2 popular brands that we work with. I'm sure there are more, but I'll just call out Docker and Apptainer. And so these would run on any virtual machine on any cloud. And so there's a sort of a cost benefit consideration here, because you have to learn how to work with containers, configure them, and use them. The black text or the black square up at the top here features a Docker run switch-v, which connects basically some local file system to something that exists within the Docker container so that you have this kind of connectivity between the outer reality of your Linux machine and the hermetic reality of the Docker container. So that's important because we need to be able to get information in and out of containers. So there we go. Containerization is a concept to file away as a method of avoiding the overburden problem I was describing a moment ago. Okay, so especially with Naomi, we like to discuss org charts. So I'd like to just lay out the landscape for a moment here. First of all, starting with us, the researcher. Hopefully we identify that in 4 roles that I mentioned. Happily computing away. And then we have the CloudBank organization, which I do in fact represent as a National Science Foundation funded project. It's a collaboration between the University of Washington, University of California, San Diego, and University of California, Berkeley. And San Diego is really the kind of the lead sled dog in this project. They have developed a portal, and I'll be referring to some of the resources there. And our objective in CloudBank is to facilitate cloud access across the board in as many different aspects of that process as we can. So if a research team gets connected up to CloudBank, then that means that you're immediately have access to the different cloud platforms. And these are the Amazon Web Services, Google Cloud Platform, and Azure Cloud. There are other clouds out there also. And the point that I wanted to make about the cloud platforms is that while the individual platforms have a plethora of services and features that are built up on the basics of compute power and storage and networking, each cloud also has an associated marketplace where third-party groups can come in and set up shop and create advanced services that are interfaced with the basic cloud platform in some way or connected in some way. So it's good to be aware of the fact that there's more to the cloud than just what Amazon builds. There's also that marketplace community out there. So in addition, CloudBank connects to the National Science Foundation, and there could be a line between the researcher and these funding agencies, but just to avoid too much busyness, the last 2 things I wanted to mention are our programs such as NAIR, the National Artificial Intelligence Research Resource Program, which we're in pilot phase, and then other programs like All of Us. So those are part of the landscape. And of course, then there's other computing approaches to computing, such as high-performance computing. And then finally, there's third-party. So for example, Databricks is a ecosystem built around Apache Spark for doing heavy-duty data science. Okay, so that's the landscape. Great, let's move on. I mentioned that CloudBank is here to help researchers be able to effectively use the cloud. We have a portal at cloudbank.org. We have some learning resources at that URL. By the way, this deck will be made available when we're done. So if these links fly by, don't worry about copying them. They'll still be available to you. We have a community website where we can discuss common themes, problems, and solutions. And then we have I guess I have a link to a CFAR on Spot VM here, which is the SkyPilot study. I think that might be renamed. So if that's the case, I'll fix that before this deck is distributed. Okay. So to further lay out the architecture of the universe here, once again, we have us, and we have the internet, which we're somehow connected to, and then we have the cloud, and so I'm gradually building up the pieces. And then there's this confusing array within the cloud of different things that you can do. There's virtual machines and serverless functions, and there are different kinds of NoSQL databases and so forth. So all these things are services. That's the generic term for things that you can pay money for on the cloud to get stuff done. And I don't want to burden this diagram with all these services beyond giving a nod to them. So I'll make that go away again. And then the thing I do want to call out is something called object storage. So if you are new to the cloud, this will be an important detail. If it's very familiar, then thank you for bearing with me. Object storage is not associated with a computer or a virtual machine on the cloud. Instead, it exists as its own thing. It has fairly fast accurate access time, so low latency. It is infinitely large as far as we're concerned. And it's quantized into things that are often called buckets or blobs. Azure calls them blobs. AWS calls them buckets. I think Google calls them buckets also. And you can give information a URL that's sitting in object storage. So if you have the means to read and write to object storage, then you have solved the important problem that we'll get to in a couple of moments here, which is storing the state of a computation while you're in the middle of doing it. And then, of course, object storage persists. So that concept of object storage is like sort of one of the first important cornerstones of being able to think as a cloud engineer. And then the second is this excess capacity of computing, which are virtual machines that exist in some kind of logical containerized way on the various clouds. So we call it the spot market. And there's a whole bunch of those virtual machines available. And just for completeness, I'm also including two other features that are connected to the internet, which are the Docker Hub, which is a kind of a repository for Docker containers so that you can place them there and then call them into existence in a Docker-friendly environment at a moment's notice. And then, of course, there's GitHub, which is our sort of default go-to repository for source code management, for document management. Okay. So this is rather long, but I'll try and burn through this fairly quickly. Checkpointing is, as I mentioned, storing the state of a computation so that the computing task can be interrupted and then resumed. Since cloud instances have unused capacity, cloud platforms should be, not instances, and these computers are available at something like 50% to 90% discount. And this is the spot market. There's catch, however. So going to the spot market and getting one of these cheap virtual machines is great as long as that machine still exists. But the condition is that these machines can be preempted when the market price exceeds what one is paying. And on very short notice, as we'll see, suddenly that machine is no longer available. So the optimization challenge is to implement checkpointing as a hedge against preemption. So checkpointing simply means saving the state of a computation. Preemption means being evicted from your spot market instance. And that's how, in principle, we will save a great deal of money or get more buying power for our budget dollar. We are currently working through preemptible instance use. And this is actually this Cloud Clinic today. This presentation is the first round of what I hope will be a series that we will evolve to basically a full-blown comprehensive set of support documentation that will really demystify the process. But for today, my goal is to simply introduce the terms and the central objective. And so to do that, I'm going to talk about checkpointing a little bit in a little bit more detail, and I have defined three somewhat whimsical modes for checkpointing scenarios. So the first mode is you've got a processing task like the CFAR10 task running on a virtual machine on the cloud that's a preemptible instance, and that task is running along, going full speed. It's not paying attention to anything else. And suddenly we are evicted from that instance. So that's the hit by a bus case. And the question is, what can you do to deal with that circumstance? The second mode is called parachute mode, and that's where you're running along doing your processing, but you're also checking every once in a while to make sure that the plane that you're flying along in is still okay and the wing hasn't fallen off. And the idea here is that you do get a signal from the cloud provider when you're being evicted, and that gives you some amount of time to respond. So if you are actively paying attention to that and through something like a polling loop, then you can catch wind of the fact that you're about to lose your instance and take action. And then finally, there's the third mode, which is the what me worry mode, which I'll get into more specifically concerning AWS spot market instances and the hibernation option. Okay, how much time do we have? Well, if we have a spot market instance on Google, then you get an ACPI G2 soft off notification, which I don't know what that is, but it's apparently some kind of a system protocol. And you have 30 seconds. So that's how much time you have if you're working with, for example, with the airplane, the parachute mode. On Amazon, you get a JSON text notification passed to the service called EventBridge. So you have to know how to poll that. And you could poll that every 5 seconds. And once you see that notification that you're being evicted, you have 2 minutes to get things done. And there's an asterisk on that one. And then the third case we have is on the Azure cloud. And there again, we have 30 seconds. And that preemption signal is sent to something equivalent to EventBridge, which is called Schedule Events, which is another service. And again, you would put that on a polling loop to notice it. Okay. So as of today, Amazon Web Services features 3 different eviction options that you can choose when you are setting up your spot market virtual machine. And these are stop, hibernate, or terminate. So terminate is exactly what it sounds like. It means your virtual machine just gets blown away. And that's the end of it. Stopping is like stopping a computer or shutting it down. So that means that it will be preserved and you could restart it at some later point. But hibernate is really nice because hibernate is actually capturing an image of the machine. And the claim is that a hibernated spot market on Amazon Web Services can be and will be restarted automatically later when the price drops back down. So if you're doing a compute task, we haven't tested this yet thoroughly, but if you're doing a compute task and you hibernate, that hibernation process should just pause the processing and then restart it again when that hibernated instance comes back to life. And then Azure features 2 different options. One of them is a stop deallocate, which is not like the hibernation. It's more like stopping a computer so that anything that's running will be summarily cut off. But at least all the configuration stuff that you've done is saved and you can restart that spot instance presumably at some later point. And delete is the same thing as terminate. So there we go. To elaborate a little bit more, I found this very nice instructive diagram of what happens when you select hibernate on the AWS spot market. So the first thing you have is a running EC2 instance in spot market, and all kinds of interesting stuff is going on in RAM. And then that notification comes in, but instead of having 2 minutes, you have 0 seconds. So the hibernation just starts happening automatically on AWS. But you don't care about having 2 minutes because this is what's going to happen. All the RAM that's in your virtual machine gets copied into this encrypted storage, elastic block storage, which is basically a disk drive in my world. And then once that RAM is copied, the system will shut down. So the RAM that's in the running machine is no longer there, but it is still persisting on the EBS volume. And then at some point later on, it gets started up. The RAM is loaded back into, from the EBS volume, back into the machine's actual RAM, and the process is continued. So this is the what me worry mode, where you don't have to worry about your process being interrupted because you have faith that it will be restarted at some point and just pick right up where it left off without losing a flop. Okay, so there we have it. Again, as I mentioned, this is an ongoing project, and there's lots of whatabouts and what ifs that we need to verify and document. So that's the process that we're in the middle of doing. But I didn't want to really sort of delay this introduction to the topic too long because this is important stuff to just sort of have the basic idea. And once you have the concept of using the spot market and checkpointing, then of course you're free to go off and figure this stuff out. And if you do, then our project would benefit from hearing from you and any wisdom or solutions that you develop and can share. Also in the process of preparing for this, sorry, hang on. Okay. I found an interesting online article by a guy named Eric Pauli on the AWS spot market. And his main point of this article is that you can often select machines for your spot instance selection that are more powerful than the machine that you think you need because the reduction in cost is so low that you end up saving a lot of money anyway. So I'll just call that out, and you can surf on over to that article if you're interested in seeing more of the details. It's really an extremely well done blog. Okay, so I think we're on the glide path to my last few slides here. To build the path for being able to do effective checkpointing, and I think we're kind of back in the, what was the first mode? The bus mode. First of all, we need some kind of a task like the CFAR10 task that I've mentioned. We need a virtual machine image on one or more clouds that are pre-configured. So by image, I mean it is a freeze-dried version of the operating system with the software that we want to run, the data, and run it start script, perhaps. It also might include the use of a container, which can be loaded, for example, when a virtual machine boots up. For our work, we are working with a false interrupt, which is creating a file that we can just touch to create it, and then that will behave as a system interrupt signal. So then if we're on a polling loop and looking for that, we can use that to simulate being interrupted. And then finally, once a virtual machine on the spot market does get preempted and it doesn't exist anymore, then we need an external agent, which I'm referring to as a watcher/launcher, which is, for example, a lightweight virtual machine that's always on, that notices a preemption and then restarts from the last check. And just to sort of reemphasize the object storage value, I've wanted to take a couple of slides here with screen captures to show that this happens to be on the Azure cloud. The same kind of thing applies to the other two clouds as well. So we have this idea of Azure Blob Storage associated with a storage account, which is a logical entity that contains different types of storage on the Azure cloud. And from that Azure Blob Storage, in the storage account, we can do something called a browser that allows us to look into the various blobs. This is the red circle is concerning, and the NAIR blob, inside of which has a file called checkpoint.txt. And checkpoint. Sorry, hang on. Yeah, so the checkpoint.txt file is presumably written by our CFAR10 process. And when that happens, that file is referred to by a URL. So I can copy that URL and I can open up pandas, I can open up Python on my laptop, import pandas and read a CSV file where I'm actually passing it the URL of the checkpoint file. And then I'm looking at the contents of that in the file. The example file that I have there is called CFAR10, is called checkpoint.txt, and the contents are CFAR10 progress and epochs. So hopefully this is a little bit helter-skelter, but the point that I'm trying to make is that I was able to read a checkpoint file from my laptop that's sitting on the cloud. And that checkpoint file can be written by a CFAR10 process that's running an extended processing run. Okay, so in the bus model, this file checkpoint.txt is written by a script that's running on a preemptible VM at regular intervals, and it's not responding to the 2-minute warning. So it's going to get hit by a bus at some point, but we don't care. And then, as I was saying, that file was retrieved by a laptop acting in the sort of the watcher starter mode. And then the thing that I didn't talk about here is that when you run these sort of access to cloud programs, particularly if you want to write something to the cloud, then there's an authentication step, and that involves passing tokens and dealing with the authentication process so that somebody who doesn't have approval can't go in and mess with your object storage files. Okay. And then I think this is about the last thing that I wanted to mention is that I have now showed some screen captures from working with the Cloud Console. All three cloud providers have their own console or portal, and we can sort of get our bearings and get accustomed to working in the cloud by simply working through that console. However, when you want to do stuff in an automated fashion, then you need to start resorting to scripts. And all the clouds have a unique scripting language. So the one for Google Cloud is called G-Cloud. And that's you install that on your computer, and then you're able to issue commands like the one shown here, which is G-Cloud compute instances create, my useful VM, etc. So going through this process on the console, you can configure a create the VM command, and then you can click on it, show me what the code looks like, and the Cloud Console will give you this text as something you can copy and paste into a script. So the idea is that they're trying to facilitate going from using the console to being able to use shell scripts. Okay. So that's everything that I wanted to say in this first round of our presentation on preemptible instances and checkpointing. As I mentioned, my presentation and the slide deck will become available, and we will be updating them as we make further progress. So to reiterate, the goal here is simply to make efficient use of cloud computing. So CloudBank hopes to demystify these topics so that the research team builder will have a usable path forward, so that the research team will get to this $30,000 worth of compute for $10,000. And so again, if you have contributions or questions, we can turn to those now. And you can also contact us through our help desk email, help@cloudbank.org. So that's it. So thank you so much for coming along with me on this. And yeah, if anybody has any questions at this point, we'd love to hear them.